Okay, right. Uh, let's say we have a cubic equation. Cubic equation is the highest power, the highest order is 3, right? 3. Okay, now there is this curve, right? There's a curve, and the curve is y equals to x bracket 1 plus x, 4 minus x. And if you know from your mathematics, this curve is go up and down like that, right? So there are two turning points. One is a maximum point, the other is a minimum point. And because they move up and down, the curve cuts the x-axis at 3 points. Okay, so actually from the equation here you can see already when you put this equals to 0, you know the 3 points, they are 0, -1 and 4. Okay, right. So this cubic equation cuts the curve at 3 points. Okay, and between the curve and the x-axis, we have two shaded area. One is between -1 and 0, and another is between 0 and 4. So there are two shaded areas. Two shaded areas. Okay, the first one between -1 and 0, this area is below the x-axis. Okay, between 0 and 4, the shaded area is above the x-axis. Now, of course, we don't know the difference, right? Now, I tell you that the difference is the area above the x-axis will give you a positive value. The area below the x-axis will give you a negative value. Any question?
Understand, teacher.
Understand? So sometimes the area between the curve and the axis, sometimes they cut across the axis. So sometimes you have above, sometimes you have below. Okay, now
Teacher,
yes,
so the value above the graph is positive, ah?
above the x-axis,
Yeah,
above
it's
the x-axis
positive.
is positive.
Then
Below
the
the
down one
is negative.
negative.
But from your knowledge of physics, area is not a vector quantity. Area shouldn't have positive and negative, but mathematically we will get this type of positive and negative area. But by right, area which is a scalar quantity has no positive and negative sign. So we have to take care of this positive and negative sign.
Teacher, then usually when we count the area above the graph, we will get negative, ah?
Above the
Or
graph is
always will
positive.
get positive one.
Below you will get negative.
If like the question, if they ask us to find the total area, then when we find the area above the x-axis, usually we will get positive value or negative value.
Positive
So
above
we
the
won't
x-axis.
get negative, ah?
Won't get unless they ask you to find the area below the x-axis, then you will get a negative value. How to
Okay,
deal
teacher.
with it? I'm going to show you how to deal with it. Okay, enough? Right. So the area, the shaded area here consists of integrate from 0 to 4. Okay, I'm now reading here. So it consists of one area, integrate from 0 to 4, y dx. Another area, integrate from -1 to 0, y dx. So we have two areas. However, the area, okay, now the y we change to fx, that one is, you should know lah, because you cannot integrate y with respect to x. So I change to fx. The part that is from 0 to 4 will give me a positive value. So I just leave it as it is. But the part that is from -1 to 0 will give me a negative value. So I put a modular sign or the absolute value sign there, so that if I get a negative value, you just change it to a positive value, so that you can add the two of them together. Otherwise, one positive, one negative, you add them together, probably they become 0 or less, right? The
So teacher
worst,
8, for the answer to count area, we cannot write in negative value.
cannot, because area is a scalar quantity, it's not a vector quantity, right? So you cannot have negative area. Knowing that it is going to give you a negative value, you put the absolute value sign there, so that afterwards when you see negative value, you change it to a positive one. But not before you integrate. After you integrate, after you substitute, then you change. Okay or not?
Okay, teacher.
Okay. So afterwards, we are going to change after the integration. Now the fx, I put in the equation, the cubic equation, and I have to expand this cubic equation, right? Just replace. Over here, I still have the modular sign or the absolute value sign there. Okay, they are the same equation. They are the same equation. Okay, just that one part I put a modular sign, the other one no need. Okay, so I try to expand the equation. From here to here, I expand. So become 4 plus 3x minus x squared, right? Then behind is supposed to be the same equation. So I don't copy down already. From here, I expand also. X multiplied by 4 is 4x. X multiplied by 3x is 3x squared. X multiplied with x squared is x cubed. So actually the front and the back, they are actually the same expression. They are the same function. Okay, same function. So now I just expand, but I need to integrate. So integrate 4x, you look at here, integrate 4x, 2x squared. Integrate 3x squared becomes x cubed. Integrate x to the power 3 is negative x to the power 4 divided by 4, right? So the front, after you have integrated, is like this. Behind, you just copy because they are the same function. So you just copy. Only difference is in the upper and lower limit. The bracket in front is 0 to 4. Bracket behind, negative to 0. Okay. Now substitute in the values. Okay. So the absolute value sign is still there. The front one, I substitute in 4. Okay, I get 32, 64, 64. Substitute in 0, all will be 0. So I just write 1 0 enough. Okay, then the function behind, the integral behind. The integral behind, you substitute 0, everything will be 0. Then minus the bracket, substitute in -1. So it will be like this. Okay, it will be like this. So you finally, the bracket in front, 64 minus 64, no more. So the bracket in front is 32. The bracket behind is -3/4. The bracket behind, we expected it to be negative, and really it turns out to be negative. So like this. But you don't take 32 minus 3/4. You take 32 plus 3/4, because absolute value will change the negative to positive sign. So when you add them together, it's 32 3/4 square unit. Any question?